So basically, bonding is done to avoid static electricity, where we join the two metals parts or pipelines so that electrical charge can continue. So you can see here that these are the on chips we have very long pipelines, so we cannot have in one piece. So different pipeline joints, that is, this is called the flange, the end part of the pipeline which is little higher side. This is the flange and this is the pipeline. So joining of two pipelines, the charge, there is some gap because of the gasket, and the charge cannot jump or pass. So there is a cable connection, a metal wire connection, or there is some other metal strips also. So this joining is called bonding. That is, bonding is joining of two pipelines with a metal wire or a metal piece, like you can see here also. So these are the various examples of bonding. So this is the bonding wire. You can see the metal piece which is put inside this nut bolts and tightened. So nut bolts also are of a metal. So charge, metals are good conductors of electricity. So charge can flow. You can see so many pipelines are there. Not necessary on bends, everywhere, even straight pipelines around, anywhere, everywhere, wherever there are joints, we need bonding, especially for tankers. So clingage is the oil remaining on the walls of the pipe or the internal surfaces of the tanks after the bulk of the oil has been removed. So you have the tank full of oil and it is discharged. So whatever crude oil is remaining on the walls and bulkheads, that is your clingage. Like if you have a vessel of ghee or some oil and that is removed, so whatever ghee or oil is remaining on the sides, that is your clingage. That's the sticking. Clingage is sticking on the bulkheads. So now let's see earthing. Earthing is also similar to grounding and bonding, but there is some difference. So if you earthing is basically dissipation of charge to the hull, to the earth, and or to the sea in case of ship, so that there is no place the charge accumulation can take place, as earth and sea are very wide, huge, and the charge can dissipate in a very big area quite easily. So the electrical connection of the equipment to the main body of the earth to ensure that it is at the earth potential. So if it is at the earth potential or potential of the same objects, then the charge will not flow. On board ship, the connection is made to the main metallic structure of the ship, that is the hull, which is at earth potential because of the conductivity of the sea. So this is your, like if there is a truck, so this is a post which is grounded to the earth, and we have a wire here. So this is your earthing or grounding connection. Same way. Then next is flammable or combustible. So regarding oil tankers, these small things I think everybody knows and should know, that anything, any oil like substance which is capable of being ignited or burning because it is forming vapors. So that is your flammability. And there is a flammable range that we will see in the flammability diagram. Then next important term is gas freeing. Gas freeing is having a tank free of any toxic gases basically. So gas is toxic gases and free of toxic gases. That is the basic meaning of the gas free. So why we need a tank, or when do we need a tank free of toxic gases? When a man entry is being made. Otherwise, if there is cargo, cargo does not get affected with toxic gases. Toxic means it is poisonous to humans only. So freeing a gas of any toxic gases is called gas free or gas free. So a tank or compartment or container is gas free when sufficient fresh air is there. First, it should be easily breathable. So you should have 21% oxygen. And has been introduced into it to lower any flammable, toxic, or inert gas to the required for a specific purpose. It is hot work or entry. So if we want to enter any tank, man entry has to be done for hot work or any other enclosed space entries inspection. So the tank should have sufficient air and there should be no toxic inert gas or flammable gases. That is called gas free. And for this, in ports, when a surveyor comes, he will give you a gas free certificate if any repairs or something have to be done. Especially you are going to dry dock where so many repairs are to be done. So first thing is you need to have a gas free certificate before entering the dry dock, because there will be so many man entries and repairs. Then next is inert gas. I hope all of you know. By the name, it suggests that inert means which is not reacting with other oils or gases. So here it is a mixture of gases such as, for example, it is flue gas. Flue gas means the exhaust gas or waste gas which is coming out of boiler, and it is not sufficient in oxygen to support the combustion of hydrocarbons. So whenever there is oxygen less than 11%, we know it will not support combustion, and that is your inert gas. And different concentrations are there for the inert gas plant requirements, less than 5% for the tank and less than 8% that we will see. So it, the plant which is delivering inert gas from boiler to the cargo tank, that is your inert gas plant. And the procedure is called inerting, that is introduction of inert gas into the tank with the object of obtaining an inert condition, that is insufficient oxygen condition. Then next important definition is intrinsically safe. Intrinsically safe is very important on tankers for circuits which do not get burnt or damaged because of the spark. So intrinsically safe is if any spark or thermal effect produced normally, that is by breaking or closing the circuit accidentally, it will not produce spark outside of the circuit by short circuit or earth fault, is incapable under prescribed test conditions of igniting a prescribed gas mixture. So if the tank is full of flammable mixture, flammable gases, and because of the any electrical circuit like your mobile, torch, walkie-talkie, any spark is coming out, it will not be able to ignite the atmosphere in the tank. That is your intrinsically safe. So for example, you have like these flashlights, LED lights, then we have intrinsically safe cameras, then your walkie-talkies. Then next, a very important topic which always asked in orals and for practical use also. There are some oils which are volatile and some oils which are non-volatile. Volatile is basically forming vapor. Like if you boil the water, it starts forming vapor at certain temperature. So that is its volatility. Water is very volatile. Same way, there are some petroleum which are having a flash point of 60 degrees centigrade or above. They are non-volatile. So above 60-degree centigrade, they don't produce sufficient vapors to produce any flash. That is your non-volatiles. The oils like petroleum, if you go to any petrol pump, you will have a lot of vapor at normal temperature also, and fire can take place. So that means it is a very volatile substance. So petroleum having a flash oil, petroleum here means oils having a flash point of 60 degrees centigrade above, which is determined by Reed closed cup method of test. They are non-volatile oils. Then next is pour point is very important in oil tankers. First thing is pour point is the lowest temperature at which a petroleum will remain fluid. So like a flow state will develop. Like if you have ghee at home, is there are some times in cold weather, if you just keep it at ambient temperature, it solidifies. So it is going below its pour point. That's why it is solidifying. So if oils inside the ship in the tanks they start solidifying, then it will be very difficult to discharge them, and the pump and tank, everything will get, lines will get choked. So it's very necessary to keep them in liquid state, and that's why the reason is we keep always all the oils. The requirement is to keep them at least 10 degrees above their pour point. So the general simple thumb rule is at least 10-degree more than pour point. We have to keep the oils. There are some other more complex requirement for different temperatures of pour point, but finally it comes down to the simple understanding that if you keep the oils 10 degrees more than the pour point, then you are in the safe zone. Then very important thing about understanding of oil tankers is there are two different types of oil classified as per the content of sulfur or hydrogen sulfide. So there are two types: sour crude oil and sweet crude oil. Sour crude oils, as the name suggests, it has more hydrogen sulfide because hydrogen sulfide is very sour or has pungent smell. Also, mercaptan used for giving a little smell to the oil. So if oil is having lot of hydrogen sulfide or mercaptan, it is sour crude oil. If it is having very less amount of hydrogen sulfide or mercaptan, it is sweet crude oils. Then there are spiked crude oil. That is, it is spiked with, like, you put some spices. That is your spicy food. Same way, spiked crude oil is mix or blend of some other liquefied gases in the oil. Then next important thing is your threshold limit value. This we have already covered more detail in the hazards of oil, but just to revise, threshold limit value, that threshold means the maximum limit of a gas of which you can be exposed if, till the limit it's not causing any harm or any physical health problems to a human. So without any adverse health effect, the safe exposure is your threshold limit value. So it is classified in three types: time weighted average, that is in 8 hours in a week, 8 hours in a day for a week. If whatever ppm of the gas, if you are exposed safely, that is your time weighted average. So 8 hours in a day for a week is time weighted average. Then short term exposure limit is for 15 minutes, 4 times in a day, with a time period of at least 1 hour gap in between them. That is your short term exposure limit. So 15 minutes short exposures, that's why it is short term exposure limit. And threshold ceiling value, that's the maximum limit of any gas in any time, which is exceeds, then you will have very bad health effects. So these are all the main definitions for oil tanker familiarization which we should know. Then we are on chemical tanker main definitions. So first thing is certificate of fitness on chemical tankers or ships carrying chemicals. So certificate of fitness is giving that the ship is complying with IBC code with all the structure and equipments. The next important thing is MFAG. It is IMO Medical First Aid Guide used for accidents of dangerous goods. That is, in chemical tankers, lot of accidents because chemicals are very hazardous. So we should know how to refer the medical guide. Then next thing is padding. Padding is like a pad, your cushion. So in the top of the tanks, when we fill inert gas, normally in oil tankers we were filling inert gas in full tank. Here, after loading, a little space which is left, the alleged space, in that we fill the inert gas to avoid reaction of cargoes which react with air or moisture, and that is called padding. So filling and maintaining the cargo tank and pipeline with inert gas or liquid in order to separate the cargo from air. So difference between inerting is we are doing in the full tank when the cargo is not there, empty tank, and padding we are doing in loaded tank, where in the empty space which is there after loading, the alleged space, to avoid the cargo reaction with the air. The next important thing is polymerization. Polymerization is some chemicals react automatically on themselves and they form some cake-like structures that is called a polymer, like you have beehives and all. So it is a phenomena where the molecules of a compound link together into a larger unit containing a two of many thousands of molecules. That is called a polymer. So we have a monomer, one molecules, there are separate molecules in normally liquids. They combine together to form a polymer, and they change the cargo properties, like styrene monomers polymerizes very fast, and the compounds they change their properties, they change their free liquid flowing state, they become viscous, or they even become solid also. Then it's very difficult to discharge them. So it can occur on its own or due to the influence of some other materials like heat and all. Like molasses is also forms become solid. So we add some powders or inhibitors, and these powders or inhibitors they prevent these cargoes to become polymer. So let's see some example. So you can see this example, like this is styrene monomer, and it was kept in the tank, and many of these molecules they join together and they polymerization took place and they become polystyrene. So this is your polymerization which we don't want. So this is what is polymerization. Like this one molecule is forming with different molecules and forming a chain. So like this, there are so many molecules. These pins you can say is one molecule, and these pins mix with together each other and they form a chain like structure like this. So this is your polymerization or polymer, which is a fiber. So the practical example is like that, if you have any chemical you add like this, just add some color to see how the polymerization is taking place, and we put a second layer of the phenolphthalein. So these you can see these two chemicals are separate, and you can see this slimy like molecules come together and react and they form a polymer. It's like a synthetic fiber, or so this is for nylon, which is formed by your polymerization. So this is what you find in your birthday parties and all, that fizz, that is your polymer. So when the Ig or nitrogen is coming and we are just putting the Ig or this thing on top of that tank just to fill this space, that is called padding. Preferably nitrogen only we are doing. I have not seen, because this padding is mostly we are doing in chemical tankers on top of the cargo. So these tanks previously they don't have Ig. After the cargo is loaded, then we put inert gas, and that is your just to cover the top part of and remove the air from the top part, because these cargoes are sensitive to air, so they react with air or the moisture present in air. So to remove the air from the top of the tank and keep them with in contact with Ig with positive pressure, that is why that is called padding. So next thing is we are going to see what is purging. Purging is basically a gas or this thing coming out of your, this is a purge pipe. You can say relating to your, whenever you have gas in your stomach, you are farting, so it's coming out. Same way from the tank, the gas is coming out from an open pipe. That is your purge pipe, which is mostly you will see in chemical tankers or some product tankers. So, what is purging is, suppose we have this tank full of hydrocarbon or some other gas, and we are putting IG in the tank. So, IG will be purged out from this pipe, correct? Or any other openings. We sometimes purge from the tank dome also.
सर तो पर्जिंग सर तभी करते हैं कि जब सर हमको टैंक फिल करने से पहले सर।
So, when we are filling IG in the tank, and the gas or atmosphere, air or hydrocarbon, whatever toxic gases in the tank are going out, coming out from the purge pipe. So, coming out of the gas from the purge pipe is your purging, only this part. So, this can be in other different cases also. So, first case we take that purging is done when we are preparing the when we are doing inerting. So, when we are inerting the tank, that time we are putting inert gas and inert gas is purged out. Now, next case is when we are doing gas freeing during tank cleaning and all. So, during gas freeing and during tank cleaning. So, this is a tank where the cargo is discharged and now it is empty. We have already washed the tank, everything, and we want to make this tank gas free or remove the vapors or not, some smell or whatever is there of because of the cargo. So, we put the gas free from the gas or air from the gas freeing line, and it is coming into the tank and it is vented out of the purge pipe. We keep on purging till the tank is free from gas and odor, and we can check from the gas meters from the here or from the tank. So, purging can be during gas freeing also and during inerting also. That is your air or this gas or vapors are purged out of the purge pipe.